You have a program, so you've got the bios on all the guys. I'm Gerry Griffin. I'm in there. Hank Rodder, Gary Johnson, Jerry Woodfill, Lonnie Jenkins, and Norm Chaffee. That's the lineup. This is a short panel to have, and I don't mean my height. It's a short panel, then we gotta get moving and get on with it. A few opening remarks. This panel came into existence because of a young man from Wales named Craig Scott. Some of you know him. He's a real student of the American space program, passionate about it. And I met him 3 or 4 years ago, and he and I have stayed in touch. He's been in touch with several of these guys over time, and he also had the distinction of meeting non-Arabian. And we all, of us that were in the program, you're going to hear more about Don. Don is 94 now, lives in Florida, and Craig has met with him several times when he's been down there. And we all wish Don well. We all had an interesting time dealing with Don, and he brought a lot to the program, but he also brought a lot to the MERD. The mission evaluation room, what was it? These guys really were the unsung heroes of Apollo. The astronauts and mission control get most of the ink, a lot of the coverage, and that's natural because we talk to the press a lot. We were air to ground, you heard all of that. But I think everybody in mission control and the astronauts will tell you this was a huge team effort. And the MERD was mission control, or the real-time operations. It was its window to all the engineering talent in the country. Not only at the centers, but at the contractors that built the hardware. So when we got in trouble, the mayor really jumped in. But an interesting point about it was very busy when things were normal, because they were analyzing, along with our guys in our back rooms in the control center and our people in the front room, they were busy, making sure everything was right. And when it wasn't, that's when they really swung into action. So when I was asked to chair this, it's kind of an honor for me to do that, because it's time that the mission evaluation room gets some attention, and these guys were all there in real time and played. So here's how we're going to try this, because we are tight on time. I've asked each one of them, and we're just going to go down the line, take 2 or 3 minutes to reflect, give you their impression of what was going on in the MERD. Some of the technical stuff we'll talk about, but we're going to try to keep it more informative about how it worked and what it did. But I've asked them if there was particularly anything poignant that they remembered about the MERD to talk about. So, Hank, can we start with you? Somebody's got to.
Hank Rodder, grew up in Central Texas. Started in 1963. I'm still working for NASA. I'm a NASA Tech Fellow for Environmental Control and Life Support Systems in Apollo. I worked the ECS system, which was the environmental control that was both active thermal and life support for both the command module and the service module. One of my jobs was to calculate for the lunar landings to make sure we were at 99% pure O2 before the LEM departed to go to the surface. And that was important because of the decompression sickness, because we were at 5 psi. When they got in the suit, they would go to 3.6 to 3.7 psia, and we didn't want anybody to get the bends on the surface. So what I would do, I had 6 or 8 pages of hand calculations. I didn't trust the slide rule those days. and I would calculate each step. We launched the limb with the equalization valves open. After we made it with the command module and pressure verified, got a good mate vestibule between the 2 patches. We opened the equalization valve in the command module and repressed the limb, and that took us from 60% at launch to into the 80s. I don't remember the exact number no more, and I wish I'd have saved those calculations. And then we had a urine vent valve where the crew could void directly overboard, and we would open that valve to purge the cabin as we were purging the nitrogen out, 40% nitrogen, which we launched with. As we were purging the nitrogen, that would flow about 0.7 pounds an hour, and that would be replaced with pure O2 from the cryo system. And so I would do calculations. I wouldn't even go through span. I'd never follow rules. And so I called up the backroom guy and said, hey, we need to open up that valve for another 4 hours to bring the pressure up, to bring the O2 up. And we did that maybe 3 or 4, maybe each day on the way to the moon. And if I needed to do a final one in lunar surf, after we rendezvous in the lunar orbit, we did another one. And so that was one of my jobs. Another job was to look at our main job was to look at anomalies of this mission and address them all for the next mission. And I would go to the Cape and watch the 3 chamber runs down there, the unmanned and 2-man crew, the prime and the backup crew, and verify the data, the performance of the service module and command module addressed it, or didn't have that existing anomaly, or we did a correction, whatever we had to do. And then I had to sign off each morning to do the next step in front of the staff. So, one interesting story. After Apollo 8, my boss and I got on an elevator, and Frank Borman walks in and gets on with us. As the door closed, he turns to us. He says, I got to hand it to you guys. I was convinced before the mission that the life support system would not keep us alive. That's the exact words. And I'm thinking, but you went anywhere? and his hero status went from here to me in my eyes. And we did keep them alive.
Well, thank you, Hank. One thing I failed to mention, the burn was located in another building. It wasn't in the control center. In building 30, it was in building 45. So it was probably 200 yards, 300 yards away, and maybe less. Anyhow, they did have data, and had real-time data, and they could get more information if they needed it from the control center or from their support people, like the contractors and so forth. So it was kind of a constant flow of data, and that's how Hank and others here were able to do that. Carl?
We would take a Polaroid shot of the data and then hand plot it. There's the Apollo 11 hand plots.
Yeah.
Every 10-minute data. Unless we had an anomaly, then we would get
Gerry, give us your impression. And you were there a long time.
Yes, I was. I was responsible for the electrical power system, distribution system, and sequencing system. Sequencing system, we had fired all our pyrotechnics and so forth, put out parachutes, separate stages, and so forth. One thing that before a mission, our campus, who's the LIM subsystem manager, and I got together, we got thinking, hey, the CSM has a battery charger. You know, we may want to top off the batteries in the LIM module sometime. So him and I got together and wrote up a procedure, and in those days, in engineering-wise, you just document it in the memo. So we put it all together, documented in the memo. Then all of a sudden, when Apollo 13 hit, guess what? Well, I was running over there to the office, get that procedure out, because we had to use that procedure in reverse. We had to use the lunar module to provide power back to CSM. So I always tell fellow engineers to always be thinking about what ifs and so forth, and they can help you out. The other situation that occurred was on Apollo 15. We were on our way to the moon. Actually, I should back up a little bit. As soon as we got into orbit, there was a little signal indication we had a fire command to the SPS engine. That is bad news and no go. It went away. Just there, short flicker, and went away. We did the TLI burn, and we were on our way to the moon. Lo and behold, here we are in 0G after that burn. That light comes on and stays on. That is a no-go for lunar orbit insertion, okay? So the SPS engine system wasn't my system, but here's a mission problem. So I got out my schematics of the SPS system, was going through it and all. And at the same time, our group was responsible for the design of all the little switches, toggle switches, circuit breakers, and so forth. So I was very familiar with the inside of the panel switches. And going through the schematics, I noticed I was trying to find out where could we pick up a ground command, because there we were switching ground to get the fire command. And I was going through and looking at all those cases, and one of them happened to be over in the instrumentation, the entry monitor system that is tied into the SPS system, but it was not in a line to fire the engine, okay? So I got to looking, thinking that toggle switch that's in there, if there was a braided wire into it that was used, and if a small braid came off, it could get loose and get down in a small crevice and get us that ground. And I said, that would fit all the data I've seen so far. So I got with Don Arabian, went over the logic with Don, and he was rigorous about it. And he said, well, it looks like you got a good case, I'll get you permission to go over to the MCC. And I went over to the MCC, but oddly enough, I was told to get with Chris Craft. Chris Craft was there monitoring the mission in the back, and that way I wouldn't get brought on the ECOMs on console. I went over my logic with Chris, and Chris says, well, sounds valid, but she said, this is so important, you've got to run a test or prove it. Well, you had a mid-course correction coming up on the way to the moon. So we got with the SPS folks and designed that particular procedure, getting ready for that test, that if everything went okay, it would prove that this short was strictly in that switch. And it turns out that was the case. We were able to go in with the Apollo 15 mission, and when we got back, they X-rayed that switch, and sure enough, that particle was at they had gone, just like I said, this one was problem.
Blow the fat out of the fire.
Right. Yeah. The other case, being responsible for the pyro system, ahead of time I was thinking, well, if my system doesn't work, we're in real trouble. And so for every one of the circuits, I worked up a procedure where you could get into the GSE connector, because on the ground, the GSE would hook up there with simulators, and you'd operate the pyro simulator. And I said, if we ever had a situation where a pyro circuit didn't work, we could go to that connector on that sequencer box in flight and hook up and make a cable and hook up to utility power and be able to operate it. One of those procedures was emergency probe retract. And we had a case on Apollo 16 where the crew had all kinds of trouble trying to dock. And many times. So once again, I ran over to the office, got my procedure, and brought it back, and we showed, of course, the connector layout, where you stuck the pins, the wire code, and so forth, and how the crew did it. Somebody said, well, somebody's got to figure out if the crew could do that. So Ken Mattingly went with me over to the auditorium, because we always kept a capsule over there. He gets out his toolkit and goes through things and gets access to the area I was talking about. And he decides he can probably make the cable also. Then we go running back to the MCC. Meanwhile, they finally docked. So they didn't need to be used. But we never did understand why we were not able to dock after 6 or 7 times. So it was a big worry when you get into lunar orbit. If you separate from the limb from the CSM and come back and not able to dock, you're in real trouble. But because we worked out, I had that emergency procedure to retract the probe and go in and make contact, the crew and flight control pressed on that. And then the other situation did get used on the first Skylab flight. The crew actually had to go use my emergency probe retract procedure to retract the probe, and then we had these outer latches that if the crew was very carefully able to go in, they'd latch up. So that basically that procedure did get finally used to save the mission.
I promise you that we talked before we came in here that we were going to be careful about acronyms and technical stuff. Now, so far we failed.
Yeah, I'm going to speak.
So we're trying to do a little better. GSE is ground support equipment, SPS surface propulsion system. Okay,
Let me go.
Jerry, in
I'm
3 to
gonna
4
get
minutes. 3 to 4 minutes.
Okay, put the clock on. 3 minutes. All right, okay. Color commentary. I'm going to do color commentary, okay. What is the MIR? Okay. I'm the guy that did the caution warning system in the MIR. So Donna Raven would call me and say, Jerry, you've got an alarm. You got an alarm. I said, yeah, it's working real well. Well, what do we do about it? I don't fix anything. I just tell you when you got a problem. But this is one of the sharpest engineers that ever worked or put on a NASA badge. This guy, he is brilliant. And Gerry Johnson's his name, and don't ever forget his name. He did more things to save mission. In fact, I believe he actually saved Apollo 15. And he has the definitive answer of what really caused the Apollo 1 fire. You go read his Apollo history and you'll know what caused the fire. Okay, well, what was the MIR? Well, the MIR, basically, it was consisted of about 1,000 employees because any engineer that worked on engineering directly could be called into the MIR to serve to do and answer a problem. And so I worked for the MIR, of course. But this guy and I are the only 2 Apollo engineers still over there. You know, we still got NASA badge and we're still working, okay? And the MIR was an area it was primitive. We sat around picnic tables. You know, we weren't like flight controllers. We didn't have chairs with rollers on it. We had to sit for 8 hours on a picnic table, a straight back chair. It was horrible. And then, you know, the flight controllers, you know, their headsets had actually microphones on it. We had no microphone. We had to use an actual telephone. But we had this. We had wonderful ability to know the. Yeah, go ahead, Hank.
We had World War II headphones.
Okay. And then in order to actually do it, but we had to have binoculars. You know, because there'd be these 7 displays, and if you're any distance from them, I was 24 years old. I didn't have a problem. But some of the more elderly were engineers. They'd have to get binoculars like Columbus looking for the New World. But we had information and knowledge, you know, and I love to tell these stories. In fact, the MIR, you know, you didn't have much time to eat. You were always on chat. And so what would happen is that you'd have to go down to the junk food machine to eat on. So guys, I'm going to give you a MIR lunch, okay? And all our MIR guys would eat honey buns. So I'm going to serve lunch, a MIR lunch. I got 6 of them. So we're all going to have a MIR lunch in it. And then we got MIR dress. You know, we're not business casual today. We are casual. So I looked it up on the internet. And if you're just casual, you don't wear a tie. You know, so we're all dressed as MIR engineers. And that's all I'm going to say. But thank you. I appreciate all the people out here. And if you want to know more about the MIR, I've got a little brochure. I've been working on this 11 years. I thank Gerry for the opportunity. And then, of course, Craig, Scott, you know, you guys made it happen. You know, so thank God for you guys. I appreciate you very much. And that's my say.
No acronyms. Okay, Lonnie.
Yes, I'm Lonnie Jenkins. I worked retired from NASA and went to Boeing, but I was doing the same thing that I'd been while I was at NASA. Really, I was to train the Boeing folks. That was a position for mission support, what we've been doing at NASA. And so I had really 48 years of this activity. Finally retired at the end of the shuttle program. So I was responsible for the MER almost all the time at that time, and even on the last two I came in. But during the MER for the Apollo program, Gerry had mentioned that how primitive it was. It was also dark. The TV screens, and we had the Polaroid shots. I had a little box that I kept my Polaroid films in, and then because it was dark, I used a lighted magnifier to see those ones. And yes, we had our graph paper and our pencils and our slide rules, and I used 11 by 18, 11 by 17 graph paper because it had more data. It's easier to see the data. Our primary mission was really to certify the next flight of one. And it was far better to do that if you look at data during real time. And we would do that with the certifications. And although we were not the primary ones responsible for finding anomalies, it was the flight controllers that did. It was surprising how often we did find problems. Mine was primarily, let's say during the flight, I was responsible, among other things, for writing or developing software, working with the contractors primarily for pressure, for quantity gauging, if you will. We didn't have a gauge per se. We had pressure and temperature that we used for that. And prior to each flight, then we would have the quantities that had been loaded with the propellant and other ones, and I would make a certification that yes, indeed, the calculations that the flight controllers had for their PVT was initially the good one. I also had developed some programs that use each pulse of it to count those up and do a backup type of quantity gauging. We had then the pre-flight items. I managed a team of analysis contractors that would write programs for our people to keep track of all of our data, both where hardware was and what our anomalies were and whatnot. And of course, continuous contact with the contractors. Anytime they did qualification, they went beyond the requirements, and we knew what those were, or we had the contractors also in the room during the MER to let us know if problems came up, how could we go beyond the flight rules and procedures that the flight controllers tested on. There was one particular mission, I think it might have been in shuttle, but in which they were so used to writing to simulating anomalies, the mission was so perfect. So I remember one of the sims where the astronauts weren't quite sure what to do. And there was one mission, I think it was a shuttle mission, in which they always assumed turbulence, and they allowed for that. And the mission was so perfect on that one, they really scrubbed the mission. But during the MER, we would, during the flights, we would then plot our data and listen to the flight directors and the flight controllers we had at that time. We were supposed to only listen to one or two loops, but I sometimes had the ability to tune in to more than one loop at a time. But we would write our mission reports, our shift reports during the flight, and hand them in, and they would go up ultimately to flight controllers. But as important, after the mission, we would get with Arabian and his group and go over the mission report line by line, editing it, and being sure that it contained all the information and it was correct.
You know, I was saying in our pre-meeting that we had, and I mentioned it yesterday in a panel with Walt Cunningham over at JSC, that those mission reports were epic, and they are great. You can download them online now. You can read back on any mission and go through. The Apollo 7 waltz was 403 pages long. And but there's one section called Anomaly anomalies that were really, really good. And so anyway, Lonnie, what else before we go to Norm?
Well, I considered that our commission was divided, provide advice and consent to the flight control.
Yeah, very good.
And each of us subsystem teams would write our own mission report for our own selves. That's what this is.
Yeah, so the mirror was really a funnel of information. I mean, it's just incredible. Norm, talk to us about it.
Great. Well, I'm Norm Chaffee. I came to JSC in 1962, and I am a rocket scientist. I'm a chemical engineer. Was working in a refinery. Decided the space program was a good deal. Came down here, and when I walked in the door, they told me, you're a rocket scientist. So that's what I became. But for the Apollo program, I was working the reaction control system, which is a system of little thrusters on both the command module, service module, and lunar module that allows the spacecraft to move, steer itself a little bit, and change its velocity in plus or minus x, plus or minus y, plus or minus z, and in roll, pitch, and yaw. So there's 12 little engines on the command module, 16 on the service module, 16 on the lunar module. And I went through, because our division had an outstanding on-site test facility at the Manned Spacecraft Center. We tested independently all of the hardware up to the systems level of all of the RCS systems, and we knew in detail how those things should operate, so we could make very good predictions working with the contractors about what was going to happen in the mission. One of the things that we did was run what you call off-limit tests. What if the pressure here gets a little higher, the pressure over here gets a little low, and the mixture of fuel and oxidizer gets off? What if the temperature is high or low? We get an imbalance in something that we're not used to. We would go run those tests. The program managers weren't real excited about that. They wanted to know if it fits the spec, don't run anything else, because if it fails, oh, that's a problem. I gotta deal with it. But we had all that data in the MER to look at it, and there were many times where those conditions did arise, where we had the data and could talk to the front room about what they might be looking for. The thing I remember, Hank talked about doing urine dumps, and one of the things that I worried about was leaking propellant valves. And when fluids leak in space, they do what you call flash into vapor, and then the rest of it freezes into snowflakes. So the crew would periodically talk about snowflakes. Well, they were supposed to report before they did a fuel cell water dump or a urine dump or something, but they didn't always do that. And then somebody would say over the loop, well, look at the fireflies. Oh, I got a leaking valve. I started looking at all my data to see if the temperature is plummeting on the valve, and then they said, oh yeah, well, we dumped the urine. Something like that. It was exciting. In the early days, you took Polaroid pictures, like Lonnie said, of the data on the screen. You had to remember the little fixer thing you had to rub the picture so it would stay there, and then you accumulate those, and then when you got a minute, you'd go and plot the data against the predictions and see how you were going. I always felt like we had enormous integrity in the MER room. We were very well respected by the front room and the contractors. We could reach out beyond our own expertise, really across the country to get anything. I want to have a few words about Arabia, because he was the being that symbolized the MER and made it happen, an outstanding engineer, but his mode of communication was screaming at the top of his voice. And I remember his deputy, Bob Fricky, had an office down at the very end of the hall and on the third floor of building 45, and Don's office was in the middle, right across from the interior room where we were sitting at the picnic tables, like somebody said. And when Don saw something, he wanted Bob Fricky to come talk about it, and he was in one of these two office things. He had the office by the window, and then his secretary had an office, and then it was the hallway, you know. So he'd sit at his desk and go, Fricky! And that would reverberate around, and then here would come Fricky running down the hall, all excited. The thing I always feared was he was going to be in the room and yell, Chaffee!
You know, it's funny because dealing with Don Arabian, as many of us have done, was always a treat. Because for one thing, his mind operated so fast, and he was, you know, he couldn't get the words out fast enough. And the faster he talked, the louder it would be. And you know, you kind of backed off there and tried to figure out what it was he was saying. But boy, you better listen, because he was always right.
Yeah, that's right.
Yeah.
All the conversations, though, were at about 70 decibels, you know.
The other thing I might mention about Don are the MERV. We had a reputation of solving problems during the missions, so between missions, some of the other centers had problems they were unable to solve. They'd call Don Arabian up, and he'd grab, depending on what it was, if it was EPS, he'd grab me, and we'd go charge it off to the Cape. We had a case with a noise problem on the first Saturn V at the pad they couldn't solve, and we got called down there to find that for them. And then one time, Marshall called, they were having a lot of unexplained electrical problems with the lunar rover vehicle. And Don got called, we went off to looking through the drawings, went down there, was able to determine what the problem was.
And since
Hank?
Norm mentioned the mid-course corrections and water dumps, we did a fuel cell water, we would have to dump every once in a while, and it'd be up to 50 to 60 pounds at a time. We did 2 mid-course corrections with the water dump. We needed less than one of his engines would do.
Well, one other skill that I gained, and Lonnie mentioned, was listening to 4 or 5 loops, you know, on your headphones at once. And you know, I still use that skill on Sunday morning when I'm listening to the political. George Papadopoulos, watch the press, and everybody's talking at once. You know,
let me jump in here, because we're almost out of time. We're gonna eat up a little bit of the next panel time, not much, because you don't start till 11 or 11:15 or something. Anyway, any questions from the audience? Do we have any questions for this? Yeah.
What was your computer house when you
Oh, the computer. On board? Almost nothing. That cell phone you're holding is a lot more powerful. More storage, faster.
mine was much larger.
Right, it was equivalent to the 386.
We had, on the first floor of the control center, we had IBM 360 75s. They were the latest, big as this room, and took all kinds of air conditioning. Your phone's actually bigger than those first 360s. So,
Command module computer was 30,000 bits. It
It's
wasn't even a Mac.
like a Commodore 64. Something like that.
To reload the software at various times for launch, on orbit, various aspects of it, and then have it really read down by the crew and be sure that it was correct load.
Yeah, and you remember we did it all in octal.
Yeah.
Because you could cram more data using octal rather than decimal. So rather than to the base 10, like we count, we were counting in that computer to the base 8. And interesting.
We weren't all that great on, least I wasn't. In fact, I was the guy that nearly kept Neil Armstrong off the moon. The alarm system, which was my responsibility, started ringing program alarms. 5 of them came on. I said, oh no, I'm going to go down in infamy. I'm keeping Neil Armstrong. Now this is where I want to compliment flight controllers, because Jack Garman and Steve Bales and Gene Krantz, they had all gone over those program alarms. So they're the ones that saved Apollo 13. Now we've been talking about the Merlin. That's one of the stories I want to tell you guys. You did a great job.
Any more questions?
I just have an observation about.
Uh-oh. This is Jerry Bostic. He lived in the control center.
Did you ever say that John was intimidated by the contractors? I wish I had a nickel for each time I heard him tell Rockwell or Drummond Gap, shut up, you don't know what the hell you're talking about.
Don was also a character that, although he'd go at you all the time during this, whenever he, like the Wolf and the dog in the cartoon, when it was lunchtime, he would call a truce and he would share his sandwiches and his apples. It was over his back.
He had the unusual attitude of test, that you don't test the specs, you test to see if it will do the job it was intended to do. The contractors don't like that.
Any more questions? Yeah, we got one right here.
I know you guys talked a lot about the hand calculations that you did. Were there any calculations that you did on the computers, or was it like you?
We didn't have.
Oh, you didn't have any.
Slide rules were
Aren't there a few hand calculations, TI?
Back aside,
Yeah, later.
Here's that with the add, the multiply, and divide.
I promised Justine, where is she? We got time for one more question. One more. Okay, let me, here we
There it
go.
is, right here.
Well, I just wanted to say, I'm working as an engineer, and just a slide rule, first time, 2 weeks ago.
It's good.
You know, I could still use one to multiply and divide, but that's all. Usually I can take square root and all kinds of stuff.
And you know what, Jerry, it doesn't have any batteries, it's digital storage and 0 gigs. So it works.
It works.
That's right. Pocket slide rule is still very useful for comparative shopping.
Okay, I think we're gonna end this panel so the next one can get ready to go. Before we close, I want to say thanks again to Craig Scott in Wales. I don't know whether this is being streamed or not, but he'll get a copy of the video if it isn't, and for making this panel happen. I want to say how honored I am to sit up here with these guys who needed the coverage. And finally, Don Arabian, thank you very much.
Thank you, Don.
Yes, sir.
Yeah.